In this example, we are given a function. So our function is sine x, and we have these values that are going to kind of play a role into whatever we're looking to do. So we're going to try to find the area function, right? So which means we're going to go from some value to x. So when we do our antiderivative, we're going to have an x in it. And so that equation is actually not representing a particular area, but it's representing an area function. So which means I could plug in any value for x and then sub it into this equation that represents the area. And so let's go through all the little pieces here. So if I do the area, that means I am doing the antiderivative from a, which is 0, to x of this function. And so if I put a t in here, this would be a sine t dt. All right, so if I do the area of this or the antiderivative, I want to do the antiderivative of sine. I don't know what the antiderivative of sine is. I don't have it memorized. So let me go through the pattern here. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of negative sine is negative cosine. And derivative of negative cosine is sine. And so we're here doing the antiderivative. Okay, so if I do the antiderivative of this, we would have a negative cosine of t, and we're going to plug in 0 and x. So we'll have a negative cosine of x minus a negative cosine of 0. All right. So negative cosine x is negative cosine x. And then cosine of 0 is 1. So that's a negative 1. So minus a negative 1 is going to simplify to a negative cosine x plus 1. And that is your area equation. And so if you want to go from 0 to pi, you just plug in pi, and that's going to tell you what the area is. Right, so that's part of what we're looking to do. And so that's our area equation. The next thing they want us to do is to graph both the original function. So we're going to graph f of x, and that f of x equals sine x. So if I graph sine x, then we have, let's say that's 2 pi. This is pi, 3 pi, 4 pi. So sine would be like this, and then this. Right? So if you think about what's happening, if you're finding the net area on this, you have this area, you're gaining area, right, until you get to that point, but then you start to lose area because you have a negative area. And so when you go one full cycle here to 2 pi, you're at actually a value of 0. Then you gain area again, then you start to lose that area, and then you start it all over again. So if you do up to from 0 to 4 pi, you would have added area, lost that area, added area, lost that area, and you'd be sitting at a 0. That's what this graph actually does for you. So if you graph the area function, and we graph this, it has a midline at 1. We do hit 1. And so if I were to kind of mimic this graph up above, and so if that's pi and 2 pi, 3 pi, 4 pi, cosine graph, it is reflected. So it's going to start at a low point, and then we're going to go to a high point, and then back to the beginning. So like that. And then we're going to hit a high point again, and then back to a low point. So here's what we want to try to make sure that we're understanding, that this is the graph of the area. So it's the graph of the area of this. So all these values represent the areas here. So you hit your highest area, your positive area at pi. So that y value represents an area. So that area is probably going to be 2, because our graph is going to go from up 1, down 1 because of the amplitude. So we're going to hit a maximum area of 2, but then you start to lose the area until you get to 2 pi, to where you get an area of 0. And then you're going to maximize your area when you get at 3 pi. You're going to have the highest area. And then you're going to start to lose that exact same area until you get back down to 4 pi. So that graph hopefully make sense of what's happening on your original curve because you're finding the area under that curve. And then the last couple questions are evaluate the area at B. So the area at B is pi over 2. Well, we have an equation for that. So we're just going to, sorry, let me fix this a little bit. Part C is us finding the area at B, which is pi over 2, which basically is us just plugging it in. So we're looking at a negative cosine of pi over 2 plus 1. So that area is cosine of pi over 2 is a 0, if I think of the cosine graph. So a cosine graph looks like that. That's pi over 2. So cosine is 0, so it's a negative 0. It's really just a 0 plus 1. That adds up to 1. So the area at pi over 2 is 1. So at pi over 2, there's pi over 2. We're at an area of 1. That's perfect. And then our other one is find the area at C. So the area at pi. So if I find the area at pi, I should be at a value of 2. So if I start to do the math, we are looking at our formula is negative cosine of pi plus 1. And cosine of pi is here. So that's a negative 1 times a negative plus 1. So 1 plus 1 adds up to 2. And so that area matches that point on the graph. So everything lines up amazing. All right. And so that was a little bit of a different take of finding the areas of pi, of sine.